What is an energy transfer?
Requires a source, whose energy is reduced, a means of transferring the energy. And an energy receiver, whose energy is increased.
What is a torr?
Measure of pressure using measurement of height of mercury in a glass tube that would create a pressure that balances the pressure of the fluid. Used to be called millimeters of mercury, mmHg.
What about pins, needles, and beds of nails?
A pin or needle has a very small area at its sharpened tip. So even a small force on it will create a large pressure at the tip, enough to penetrate cloth or your skin.
What is entropy?
A measure of the dispersal of energy. The greater the energy is dispersed, the larger the entropy. As a consequence of the second law of thermodynamics is that the entropy of the system and the environment can never decrease.
What is precision?
How well the results can be reproduced.
How can you construct your own Leyden jar?
You can use either a glass or plastic container that has a tight-fitting cap. Use a small nail to make a hole in the center of the cap. Straighten a paper clip and push it through the hole. Make sure the end of the clip reaches the bottom of the jar. Cover the outside of the jar with aluminium foil and fill the jar about 2/3 full of water. Make sure that the jar cap is dry. Now rub a plastic pen with wool and touch the pen to the paper clip. Repeat the rubbing and touching several times. Then touch the clip with your finger. You should feel a very tiny shock. The jar has stored the charge that you gave the pen when you rubbed it.
Does the momentum of your hand change?
Of course, your hand is just a part of your body. And if you are standing firmly on the ground, your body is unlikely to move. Let's pick a simpler situation. Suppose you are sitting in a desk chair with wheels on a smooth floor and you catch a heavy ball thrown by someone. In this case, you and the chair will roll backward. In other words, the momentum of you and the chair will increase as the momentum of the ball decreases.
How can that be?
Even though the nails have very tiny tips and would certainly penetrate the skin if there were only one. Because there are dozens of nails in the bed. The person's weight is distributed over many nails, and the force of each nail is quite small. The pressure is not enough to penetrate the skin. Anyone doing this demonstration has to take precautions. The parts of the body not on the lower bed have to be supported at the height of the nails. If the concrete block is broken, the person must wear safety goggles. And a sheet of wood should be held to keep any concrete from flying into the person's face.
But if you kept dividing the amount of material into smaller and smaller pieces, what would you obtain?
Democritus, a Greek who lived around 410 BCE and was the student of Leucippus of Miletus, ca 435 BCE. Stated that all matter is made up of atoms and the void. Atoms are the smallest piece into which an element can be divided, they are uncuttable. They could be neither created nor destroyed, and thus were eternal. The void was empty space. This viewpoint was expanded by the 1st century BCE by the Greek Titus Lucretius Carus. 95 to 55 BCE, in his epic poem on the nature of things. Aristotle, on the other hand, regarded the atomist philosophy as pure speculation that could never be tested. He rejected the possibility of empty space and believed you could divide matter until it was infinitely small. The Greeks were not the only ones to develop a philosophy of atomism. The Indian school of philosophy known as Valsesica, and in particular the philosopher Kanada in the 2nd century BCE, held that earth, air, fire, and water could be divided into a finite number of indivisible particles. These ideas were adopted by several other Indian schools of philosophy.
What happens if an object is not dropped, but is thrown up or down?
Physicists would say that the ball has been given an initial velocity. But this initial velocity doesn't affect the force of gravity on the ball. So the ball would still gain a downward velocity of 9.8 m/s each second it is in flight. Suppose the ball is thrown down with a velocity of 2.0 m/s. Then at time t equals 0, the time it was thrown down, it would already have a velocity of 2.0 m/s downward. If you use the table above, you see that 0.10 s later it would have a velocity of 2 plus 0.98 m/s equals 2.98 m/s. Half a second after launch its downward velocity would be 2 plus 4.9 m/s equals 6.9 m/s. That is, the initial velocity is just added to the increasing velocity caused by the gravitational force. Now suppose the ball is thrown upward with the same 2.0 m/s speed. Now we have to be very careful with the sign of the velocity. We have chosen the downward direction as positive. So the initial velocity of the ball is actually minus 2.0 m/s. The gravitational force acts in the downward direction. By Newton's second law, that means that the ball will slow down at a rate of 9.8 m/s each second. After 0.1 s it would be going minus 2.0 plus 0.98 equals minus 1.02 m/s. After 0.20 s it would be going minus 2.0 plus 1.96 equals minus 0.04 m/s. It is almost at rest. But the gravitational force is still acting on it. So it continues to accelerate downward. After 0.30 s it would be going minus 2.0 plus 2.94 equals plus 0.94 m/s. That is, it would now be moving downward.
What is an ampere, A?
Unit of measure of electric current. Equal to 1 coulomb of charge passing through a wire divided by 1 second.
Has Einstein's theory been tested?
It has been tested in many ways. It is being used every day in adjusting the clocks in GPS satellites. They run faster because they are at high altitudes where the distortion of space-time is smaller. Both the effects of special relativity, clocks running slower, and general relativity. Clocks running faster must be used to keep the clocks running accurately.
Why did Einstein win a Nobel Prize for the photoelectric effect, but not for relativity?
Einstein was a controversial person. He was Jewish and a strong supporter of pacifist causes. In addition, his approach to theoretical physics was very different from physicists of that time. He was repeatedly nominated for the Nobel Prize, but members of the prize committee, despite his public fame, refused to grant him the prize. Most likely for political reasons. The 1921 prize was not awarded. In 1922 the committee found a way to compromise. Einstein was awarded the 1921 prize for the photoelectric effect because of the way it could be tested experimentally.
What is a sonic boom?
A sonic boom occurs when an object travels faster than the speed of sound. The boom itself is caused by an object, such as a supersonic airplane, traveling faster than the sound waves themselves can travel. The sound waves pile up on one another, creating a shock wave that travels through the atmosphere, resulting in a boom when it strikes a person's ears. A sonic boom is not a momentary event that occurs as the plane breaks the sound barrier. Rather, it is a continuous sound caused by a plane as it travels at such a speed. But the shock wave travels with the plane, so we hear it only when the plane is in one location. Supersonic planes, such as this F-15 fighter jet, can go beyond Mach 1. When they do, they generate a sonic boom caused by sound waves piling up and creating a shock wave. All objects that exceed the speed of sound create sonic booms. For example, missiles and bullets, which travel faster than the sound barrier, produce sonic booms as they move through the atmosphere. The shock wave created by an F-15 fighter plane, for instance, is visible.
What is optics?
Optics is an area of study within physics that deals with the properties of and applications of light. Optics can be used not only with light, but with other parts of the electromagnetic spectrum, including microwaves, infrared, visible, ultraviolet, and X-rays.
Are there yet more quarks and leptons?
There are two more generations of both quarks and leptons. In the second generation, the quarks are called strange and charm. The strange quark was named after particles that contain these quarks. The particles decayed in very different ways and were therefore called strange particles. The charm quark was found in a particle that had a very long, or charmed life. The leptons are the muon and muon neutrino. The muon was first called the mu meson before its true identity was discovered. In the third generation, the quarks are called bottom and top. The leptons are called tau and the tau neutrino.
Who was the first American to win the Nobel Prize in Physics?
In 1907, for the development of extremely precise measurements for the velocity of light and his work on optical instruments, German-born Albert A. Michelson, a naturalized U.S. citizen, won the Nobel Prize in Physics.
What is a gas?
State of matter in which the atoms are about 10 times further apart than liquids or solids, and forces between them are very weak. A fluid that assumes the shape of its container.
What is the plum pudding model?
Swarm of electrons in a positively charged sphere.
Does a musical tone have a single frequency?
It does not have a single frequency, but many. To understand why, consider a stringed instrument like a guitar, piano, or violin. The string can oscillate in response to it being plucked, hit, or bowed. Standing waves will be formed as they would be if you shook a rope back and forth. By shaking it at different frequencies you can make it oscillate in several different modes. The lowest frequency results in nodes only at the ends. Twice this frequency produces nodes at the ends plus one in the middle. 3 times the lowest frequency give nodes at the ends plus 2 nodes at 1/3 and 2/3 its length. If you pluck, hit, or bow the string of a stringed instrument you cause it to vibrate. In many of those nodes at the same time, depending on the location you plucked it. The lowest frequency of oscillation is called the fundamental frequency. Plucking the string 1/4 from one end results in oscillations at 2, 3, 4, 6, and 7 times the fundamental frequency. The higher frequencies are called harmonics. For example, if the fundamental frequency were middle C, 256 Hz, then the second harmonic would have a frequency of 512 Hz, the third 728 Hz, the fourth 1024 Hz, etc. The sound made by the vibrating string is very weak. On acoustic stringed instruments the strings pass over the bridge that transmits the oscillations to the top plate of the body of the instrument. Low-frequency sounds also excite oscillations in the ear and in the bottom plate of the guitar's body. Sounds from the oscillations of the ear pass through the sound holes in the top plate into the surrounding air. The amplitude of the fundamental frequency is the largest. The relative amplitudes of the higher harmonics depend not only on the string, but the shape and size of the body of the instrument. Electric guitars will be discussed in the chapter on magnetism. The relative intensities of the higher harmonics depend on the instrument. The sound spectrum produced by the instrument is characterized by these relative amplitudes. The spectrum is also called the quality of sound, or the timbre. The sound quality also depends on how the sound starts and stops.
What astronomical methods have been used to measure the speed of light?
The Danish astronomer Ole R. Zero Mayer, 1644–1710, measured the orbital period of Jupiter's innermost moon, Io. He found the period was shorter when Earth was approaching Jupiter than when it was moving away from it. He concluded that light travels at a finite speed and estimated that it would take light 22 minutes to travel the diameter of Earth's orbit. Christian Huygens combined this estimate with an estimate for the diameter of Earth's orbit. He concluded that the speed of light is 220,000 kilometers per second. In 1725 the English astronomer James Bradley noted that the location of a star changed with the seasons. he proposed that the shift was due to the addition of the speed of light and the speed of Earth in its orbit. Bradley observed the shift in several stars and determined that light traveled 210 times faster than Earth in its orbit. The modern result is 10,066 times faster.
What is reflection?
When light strikes an object, it can either be absorbed, transmitted, or reflected. Opaque objects absorb or reflect light. Transparent and translucent materials transmit light, but can also reflect it. The energy carried by the light must be conserved. The sum of the energy reflected, transmitted, and absorbed must equal the energy that strikes the material. Light energy that is absorbed increases the thermal energy of the material, so the material becomes warmer. Reflection occurs when light bounces off of a surface, such as a mirror or a sheet of paper. A smooth surface, like that of a mirror, reflects light according to the rule that the angle of incidence equals the angle of reflection. Light that strikes the surface at, for example, 30 degrees above the surface is reflected at 30 degrees above the surface. You can test this for yourself with a small flashlight, a mirror, a sheet of paper, and a helper. Hold the piece of paper. Have the helper hold the flashlight. Aim it at the mirror, and move it around until the reflected light ray hits your piece of paper. Change the angle with which the light from the flashlight strikes the mirror and see that you have to move the paper closer to the mirror to have the light hit it.
What are ultra-high frequency, UHF, waves?
Frequency 300 MHz 3 GHz.
How are refrigerator magnets made?
Examine a refrigerator magnet. It is flexible, feels like rubber, and only one surface is attracted to metals. It doesn't stick to a stainless steel door unless the stainless has been coated with steel. It's made of rubber that has been impregnated with ferrite particles and magnetized. Small pieces, each a dipole, are then pressed together under heat to bond them into one thin sheet that can be cut, folded, and bonded to other sheets.
Where is the largest radio telescope?
The largest single radio telescope is the 305-meter, 1,000-foot, diameter Arecibo telescope, located in Puerto Rico. The reflecting dish, made of 40,000 perforated aluminum panels, is located in a mountain valley. The actual antennas are in a 900-ton platform, suspended on cables 137 meters, 450 feet, above the dish. The antennas, sensitive to frequencies from 50 MHz to 10 GHz, detect signals collected by and reflected from the dish, and can be moved to determine the direction from which the signals are coming. Arecibo also performs radar astronomy using a 1 MW radar transmitter to send signals to the other planets. The telescope then detects the faint echoes.
What is a mirage?
Mirages typically occur on hot summer days when surfaces such as sand, concrete, or asphalt are warm. Mirages look like pools of water on the ground, along with an upside-down image of a building, vehicle, or tree in the distance. As one approaches a mirage, the puddle of water and the reflection seem to disappear. A mirage occurs because of a temperature difference between the air directly above the surface, which is hot and thus less dense, and the cooler, denser air a few meters above the surface. The denser air has a higher refractive index, and that causes the light from an object to bend up toward the observer. As a result, the object is right side up while the refracted image is inverted and underneath the original object. The illusion of water is also a refracted image, the image of the sky. Mirages can only occur on hot surfaces and objects that are at relatively small angles in relation to the observer. Therefore, a person cannot see a mirage from an object that is just a few meters away. A mirage is not a hallucination, but instead a true and well-documented optical phenomenon.
Are there different names for auroras in the northern and southern hemispheres?
An aurora in the northern hemisphere, known as the Northern Lights, is officially called aurora borealis, while an aurora in the southern hemisphere, or southern lights, is called the aurora australis.
When it is at its maximum height, does it stop?
At an instant in time it is indeed at rest. But it doesn't stay motionless for any time interval because the gravitational force keeps acting on it.
What is a force, F?
A push or a pull on an object by an external agent, vector.
What is a light interference?
Light waves from two closely spaced slits or two surfaces of a thin film that produces regions of bright and dark regions.
What is the Snell's law of refraction?
Describes how light behaves at a boundary between two different media.
What combination of charges causes attractive and repulsive forces?
As you observed, unlike gravitational forces, which only attract masses to each other, electrostatic forces can either attract or repel charges. Like charges, positive or negative, repel each other. Unlike charges, positive attract each other. A common phrase describing many human social relationships. Opposites attract, holds true for electrostatic forces.
What is aerodynamics?
Aerodynamics is an aspect of fluid dynamics dealing specifically with the movement of air and other gases. Engineers studying aerodynamics analyze the flow of gases over and through automobiles, airplanes, golf balls, and other objects that move through air. They also study the effect of moving air on buildings, bridges, and other static objects.
What is water pressure?
Pressure is the force divided by the area over which it is exerted. In 1647 the French scientist Blaise Pascal, 1623 to 1662, recognized that water exerts the same pressure in all directions. This statement is known as Pascal's principle. To understand Pascal's principle, think of a small cube of water as shown on page 96. The gray arrow in the middle is the force of gravity on the cube. As a result, the total downward force of the cube is larger than the upward force. Now, by Newton's third law, the outward force of the water is equal to the inward force on the water.
Inclined plane?
Simple machine used to help lift an object.
What is a qubit?
Quantum bit, the basic piece of information for a quantum computer.
Which one goes faster?
You probably found that the one without the added mass sped up more. That is, for the same force, the greater the mass, the less the acceleration.
Are pulleys really simple machines?
A fixed, or unmovable, single pulley can be considered a wheel and axle where both have the same radius. The mechanical advantage is one, but the pulley changes the direction of the force. If the pulley is allowed to move and the output force is exerted by the axle of the pulley, then the input force is shared by the two ends of the rope. If you fasten one end and pull up on the other, then you achieve a mechanical advantage of 2. A combination of fixed and movable pulleys is called a block and tackle. Archimedes is said to have pulled a fully loaded ship using a block and tackle. Energy loss in a block and tackle comes from friction between the axle and its holder, as well as the stretching of the rope and rolling friction between the rope and pulley.
What is farsightedness and what can be done to correct it?
Farsightedness, or hyperopia, occurs when the lens of the eye can see objects far away, but cannot focus in on objects at closer range. The cornea and lens of the person with farsightedness cause the image to focus behind the retina, resulting in the images from objects close to the eye to be blurred. In order to correct for farsightedness, a convex lens is used to converge the light rays closer together, permitting the image to fall on the retina. The rigidity in the eye lens that affects older people, making them unable to focus on close objects, is called presbyopia.
How can you reduce the bending of a beam bridge?
The simplest way to keep the roadbed from bending is to use a king post. In the illustration below, the downward force of the center of the bridge pulls down on the vertical post. This places the diagonal braces under compression. They transmit the force to the piers. The upward force on the post makes the net force on the post 0. It is under tension. While the king post bridge can reduce the bending in the center of the bridge, it can do nothing about bending between the pier and the bridge center. One solution is to add a second vertical post and connect the two by a horizontal member, creating a queen post bridge. But a method that allows much more support on a longer bridge is the truss. Similar methods of translating downward forces to compression forces exerted on the piers on the ends of the bridge were known to the Romans who worked in stone and concrete. They were famous for the arches used in their massive aqueducts. One such aqueduct, the Pont du Gard, was completed in 18 BCE and was used to carry water a length of 270 meters. 886 feet, over the Garden River Valley in southern France. Cables suspending or holding up the roadbed are draped over a set of tall vertical towers called pylons. The pylons support the suspension cables from which vertical cables are attached that lift the deck. The ends of the suspension cables must be anchored into the ground at each end of the bridge to exert the tension forces on the cables. The first known suspension bridge was constructed in the 7th century CE by Mayans at their capital Ixtlan, Mexico. It spanned 100 meters.
What is light?
An electromagnetic wave to which human eyes respond.
How is the friction between two surfaces characterized?
In most cases the frictional force is proportional to the force pushing the surfaces together, N. This proportionality is usually written as friction equals mu asterisk N. The Greek letter U, mu, is called the coefficient of friction. It is important to remember that the two forces, friction and N, are not in the same direction.
If two objects interact, what happens to the momentum of the other object?
According to Newton's third law, if your hand exerts a force on the ball exerts a force on your hand. Thus there must be an impulse on your hand.
What are the two ways to charge an object?
When a rubber rod is rubbed with fur, the fur transfers electrons to the rubber rod. The rod and fur, originally neutral, are now charged. If an object touches the rod, some of the excess electrons on the rod can move to the object, charging it. The rod, which is now negatively charged because it has excess electrons, can attract positive charges. This method is called charging by contact. But, as you observed with the cellophane tapes, your hand and other neutral objects attract both positively and negatively charged objects.
What is nuclear fusion?
Nuclear fusion is the opposite of fission. Two nuclei join, or fuse together, forming a more massive nucleus. The mass of the resultant nucleus is less than that of the reacting nuclei, so energy is released. Because the reacting nuclei are both positively charged, there is a large repulsive force between them. To overcome this force, the reacting nuclei must have very high energy. Fusion was first observed by the British physicist Mark Oliphant. 1901 to 2000, in 1932. A typical fusion reaction involves two isotopes of hydrogen, 2H, or deuterium, and 3H, or tritium. They fuse to produce 4He, releasing a neutron. The energy released is more than 1,000,000 times larger than that released. When an electron combines with a proton to produce a hydrogen atom, nuclear fusion occurs naturally in stars like our Sun, but reproducing a fusion reaction in the Laboratory has proven to be very difficult because it takes a lot of energy to fuse nuclei together.
Are there other ways pulleys can be used?
Two or more pulleys, on fixed axles, can be connected together with a belt. If the two pulleys are of different diameters, then the one with the smaller diameter will turn faster, and thus it can exert a larger torque. In your automobile, one or more pulley and belt systems are used to deliver torques from the engine to the valve crankshaft. The water pump, the air conditioning compressor, and the alternator. Continuously variable automobile transmissions are used in a few modern cars to connect the engine to the drive shaft. The torque that can be delivered by an engine depends on the rotational speed. The torque is maximum at an intermediate speed. A transmission is designed to allow the engine to revolve at a speed where it can deliver torque to the drive shaft. The axle, and the wheels that are revolving at a variety of speeds. When the auto is accelerating from a stop, the wheel rotation speed is slow. And so the transmission needs to match a large diameter pulley attached to the engine to a smaller one connected to the drive shaft. On the other hand, when the auto is traveling at a high speed, the engine can revolve at the same or even a smaller rate than the drive shaft.
What is a mirage?
Occurs when there is a temperature difference between the air directly above the surface, which is hot and thus less dense, and the cooler, denser, air a few meters above the surface.
What exerts the downward force on the top of the cube?
If the cube is not at the top surface, then the force is exerted by water above it. If it is on the top, then air pressure, which we will discuss shortly, exerts this force. Because the downward force exerted by the fluid is greater than the upward force, the force, and hence the pressure, increases as the depth of the fluid increases. So the pressure at the bottom of a container of fluid is greater than at the top. The amount of increase in pressure is given by the product of the density P, the gravitation field strength G, and the depth H, or PGH. That is, the pressure on the bottom, L bottom equals top plus PGH.
What is white light?
White light is the combination of all the colors in the visible light spectrum. When separated from each other, the different wavelengths have different colors. The longest wavelength light is the color red, and decreasing wavelengths result in orange, yellow, green, blue, indigo, and finally, the shortest wavelength visible color, violet.
What is a laser?
Light source using stimulated emission of radiation invented in 1960 creates tiny spot of very intense, monochromatic light.
What is infrasound?
Whereas ultrasonic sounds are frequencies above the human bandwidth of hearing, infrasonic or subsonic sounds are those frequencies below the human bandwidth of hearing, or 20 Hz. Infrasounds as low in frequency as 0.001 Hz are produced by a variety of natural sources like earthquakes and volcanoes, as well as man-made structures and nuclear explosions. Elephants are known to make sounds as low as 12 Hz, and can communicate in this way over large distances.
What is a sphygmomanometer?
Device used to measure blood pressure.
What is Newton's second law?
If a net force acts on an object, it will accelerate in the direction of the force. The acceleration will be directly proportional to the net force and inversely proportional to the mass. That is, A equals Fnet/m or Fnet equals ma.
What is a stealth plane?
Stealth aircraft are planes that are able to avoid radar detection. The materials on the plane's surfaces and their peculiar shapes and angles deflect radar waves away from the plane. Or in some instances, the plane's outer fuselage can actually absorb the radar waves without reflecting it back to the enemy radar transmitter. Refer to the Fluids chapter for more information about aerodynamics and aviation.
Who won the Nobel Prize for their work in superconductivity?
Three American physicists, John Bardeen, Leon N. Cooper, and John R. Schrieffer, explained why superconductivity occurs in metals and alloys. Their development of the BCS theory for superconductivity was cited when they won the Nobel Prize in 1972. 15 years later, two other physicists won the Nobel Prize for discovering superconductive materials that achieved zero resistance at temperatures thought to be too high for superconductors. Physicists George Bednorz and Alex Muller of IBM found that a ceramic substance called lanthanum barium copper oxide became a superconductor at 35 kelvins.
What is the newest hybrid of bridges?
One of the newest, prettiest, and most economical bridges is the cable-stayed suspension bridge. With its sleek lines and thin roadways, it is the perfect bridge for most mid-span designs. The Tatara Bridge, in Onamiki, Japan. Completed in 1999, is the longest cable-stayed bridge in the world, with a span of 890 meters, 2,919 feet. Cable-stayed bridges suspend the roadbed by attaching multiple cables directly to the deck supporting the roadbed. These cables are then passed through a set of tall vertical towers and attached to abutments on the ground. Such engineering methods reduce the need for heavy, expensive steel and the massive anchorages that are needed to support suspension bridges.
How is radio astronomy different from radar astronomy?
Radar astronomy measures the reflections of transmitted radio waves to determine an object's size, position, velocity, and surface characteristics. Radio astronomy is like optical astronomy, but it uses the VHF, UHF, and microwave portions of the electromagnetic spectrum rather than the infrared and visible portions. Radio waves penetrate the dust that hides the centers of galaxies and obscures regions where stars are forming. They can also detect hydrogen gas that constitutes 85% of the known mass of the universe.
What is frequency, F?
How many cycles of an oscillation occur per second?
Why are lightning rods effective in keeping tall trees and homes safe from lightning?
Lightning rods are pointed metal rods that are installed above a tree or rooftop to protect the object. The rod, connected to the ground by a metal wire, both encourages and discourages a lightning strike. The rod discourages the lightning strike by leaking positive charges out of its pointed top to satisfy the need for positive charge in the clouds. If the rod cannot leak out enough charge to satisfy demand, the stepped leader from the cloud is instead attracted to the rod, and a flash of lightning occurs. Therefore, the rod attempts to discourage lightning, but if it cannot satisfy the negative charge, it attracts the lightning to the rod instead of the tree or house. If the lightning rod doesn't have a good connection to the ground through the wire, it can increase the danger to the building. Often these heavy grounding wires come loose from the lightning rods, and if the rod is then hit by lightning, the charges will flow along the surface of the building to the ground and could cause a fire. The rods can become disconnected from lack of routine maintenance. It is wise to check these connections on a regular basis.
If you open your eyes underwater, can you see out of the water?
Another example of total internal reflection can be seen when you are underwater. If you look straight up out of the water, you will see the sky and any other visible surroundings directly above the water. If, however, you look out of the water at an angle of 48 degrees or more from the vertical, you will not see out of the water, but instead will see a reflection from the bottom of the water. The next time you are in a pool or a lake, try looking up out of the water and you will see a point on the surface where you no longer can see out of the pool, for the light has reached its critical angle.
Do electric eels really use electric fields to capture their prey?
Electric eels do indeed set off electrical pulses to stun and even kill their prey. These eels have special nerve endings bundled together in their tails that can produce 30 volts in small electric eels to 600 volts in larger eels. Besides using the electrical shocks for hunting, the eels produce a constant electrical field for use in navigation and self-defense. Most people do not have to worry about encountering electric eels, however. This variety of eel is native only to the rivers of South America.
What is the standard model?
The description of all the particles described below is called the standard model. A model is something like a theory in that it is intended to explain observations. But it is not as complete as a theory. The standard model works very well, but there are still many questions about it. Some of these will be explained below.
What is radar?
Radar is an acronym for radio detection and ranging. A radar installation emits electromagnetic waves and detects the waves reflected from an object. It measures the time for the echo to return to find the distance of the object. The radar dish is constantly rotating, permitting it to find the direction of the object as well. Radar is used in many different arenas, but was first used in World War II to detect the approach of enemy bombers.
What is nuclear fission?
Radioactive nuclei can decay in another way: they can split in two. This process is called spontaneous fission. Fission can also be produced artificially by bombarding nuclei with low-energy neutrons. In fact, fission was discovered in this manner.
What is kinetic energy, K or K?
Energy of motion, K equals 1/2 mv2.
How many nations have nuclear weapons?
The Soviet Union exploded a nuclear device in 1949. It was similar to FAT. Man and was built using information delivered to that country by spies. China, Britain, and France developed nuclear weapons in the 1950s. South Africa had nuclear weapons but abandoned the program. Israel is suspected of having weapons, but has never admitted it. India and Pakistan have both tested nuclear weapons. Iran and North Korea are suspected of developing nuclear weapons. By 1953 there had been 50 above-ground tests of nuclear weapons that created radioactive fallout, contaminating milk and animals. These effects alerted the public to the danger of such testing. The Cold War, however, created an atmosphere in which treaties could not be negotiated. In 1963 a partial test ban treaty was signed, prohibiting tests in the atmosphere, underwater, and in space. In 1968 the Nuclear Non-Proliferation Treaty was signed. Non-nuclear weapon states were prohibited from building or acquiring nuclear weapons. Many nations have signed the treaty, although some major states did not on the basis that it makes no effort to curb development by states that already have such weapons. In 1996 the Comprehensive Test Ban Treaty was adopted by over two-thirds of the members of the United Nations General Assembly. The United States has signed but rejected ratification in 1999. Nevertheless, 337 facilities around the world monitor compliance with the treaty. They send data to a center in Vienna for analysis and distribution to the states that have signed the treaty.
How can the rocket take off?
Now the momentum of the gas and rocket isn't conserved, but still the impulse the rocket gives? The gas in pushing it backward is equal and opposite to the impulse the gas gives the rocket. Thus the rocket rises, just more slowly than it would if there were no gravity.
What is matter?
Ancient people in many parts of the world believed that all matter was made of 4 elements: earth, air, water, and fire. No matter how small an amount of material you had, you could not separate an element into a combination of other materials.
What is thermal energy?
Thermal energy is the random kinetic energy of the moving atoms and molecules that make up matter. But objects expand when heated, so the bonds holding the atoms together stretch. That means they have more elastic energy. So thermal energy is the sum of the kinetic and elastic energy of the atoms and molecules, and the bonds that hold them together. It is energy that is inside the object, and so it is called a form of internal energy.
What is a tevatron?
Very high energy synchrotron at Fermilab, near Chicago, Illinois.
What is translucent?
Media that allow light to pass through, but that bend closely spaced rays into different directions.
Does this look like the original analog signal?
No way. Note that there are two problems. First, the wiggles in the wave are missing. Second, with only 8 choices of voltages, the vertical resolution is too small. To make a more accurate conversion, you need to sample the wave more often. At least every 0.1 millisecond, and to allow more than 8 voltage choices, 32 or more would be better. To obtain the quality of sound in a CD, the sampling interval is 22 ℏs. 22 microseconds, and there are at least 4096 voltage choices.
What makes an object positively charged, negatively charged, or neutral?
The massive nucleus of an atom consists of positively charged protons and unchanged charged neutrons. It is surrounded by a cloud of negatively charged electrons. Normally atoms are neutral, the number of electrons equals the number of protons in the nucleus. A negatively charged object is an object that has an excess of electrons. A positively charged object has fewer electrons than protons in the nucleus.
What is the fastest aircraft?
Just like Chuck Yeager's Bell X-1, which was the first plane to break the sound barrier. The X-15A2, the fastest aircraft ever built, was dropped from the belly of a B-52 bomber. When released, the XI-5A2's rockets ignited, taking it to a maximum speed of 4,534 miles per hour. That speed, which is equivalent to 7,297 kilometers per hour, is Mach 6. The X-15 series flew 199 flights before being retired in 1969. The State Route 71, Blackbird, was the fastest known aircraft that can take off under its own power. It was retired in 1998.
What is general relativity?
Study of the descriptions and explanations of the causes and effects of gravity.
What is a focal point?
Location where light rays from a very distant object are reflected from a mirror or refracted by a lens to come together.
What plays the role of momentum in rotational motion?
The angular momentum of a rotating object is proportional to the product of its moment of inertia and its angular velocity. If there are no external torques on the object, then its angular momentum does not change. An object with linear momentum that has no external forces on it cannot change its mass. So its velocity is constant. But a rotating object can change its moment of inertia, so even without external torques, its rotational speed can be changed.
What is the R value?
Measure of resistance of material to heat transfer. R is the inverse of conduction, R equals 1/U.
What is the third law of thermodynamics?
The third law of thermodynamics states that absolute zero, the lowest possible temperature, can never be reached. The entropy of a system is zero at absolute zero. A procedure can remove a portion of the entropy, but not all of it. Thus it would take an infinite number of repetitions of the procedure to reach absolute zero. It's been possible to achieve temperatures as low as a few billionth of a Kelvin. But it has never been able to reach absolute zero.
What is a standard model?
Presently accepted description and explanation of subnuclear particles and their interactions.
What is entropy?
The German physicist Rudolf Clausius, 1822–1888, was concerned about Carnot's use of the term waste heat. He developed another version of the second law that involves the concept of entropy. Entropy can be defined as the dispersal of energy. The greater the dispersal or spreading, the larger the entropy. For example, when salt and pepper are in separate piles, the two substances are in distinct locations. If you mix them together, they are no longer in separate regions of pure salt and pure pepper, but dispersed throughout the combined pile. Further, it is not possible for the salt and pepper grains to separate themselves. Thus the mixing of salt and pepper increases the entropy of the system. If the salt and pepper could be shaken in such a way that they would separate, then entropy would be decreased. But such an event has never been observed. Suppose you place ice in water. Ice and water are separate. The water has higher thermal energy, the ice lower, and so the system has low entropy. When the ice melts, the two can no longer be separated. The thermal energy is dispersed throughout the system, so the entropy has increased. But wait, you might say, the ice water, the system, has cooled the air around it. The environment, decreasing its entropy because hot gas has greater entropy than cold gas. Calculations, however, show that the increase in the ice/water mixture is greater than the decrease in the air. So a statement of the second law is that the entropy of the system and the environment can never decrease. The increase in entropy suggests a direction of time, sometimes called the arrow of time. The forward direction of time is the one in which entropy increases or remains the same. Clausius had given Carnot's work a firmer foundation. Later work by Ludwig Boltzmann, Josiah Willard Gibbs, and James Clerk Maxwell developed the statistical basis for entropy.